that an element has multiple isotopes. On the periodic table, we are given the average atomic mass for that particular element. In this lesson, we are going to look at a technique called mass spectrometry. By looking at a mass spectrum of a specific element, and within this mass spectrum, it has multiple peaks that will give us information about specific isotopes. For instance, the mass spectrum for neon show 3 peaks that is given above to us at the mass per charge ratios of 20, 21, 22, with relative abundance of 90.48%, 0.27%, and 9.25% respectively. So I draw a quick sketch of what the graph might look like right here. So here you have a mass per charge right here of 20 will give you this peak, which is 90%, 0.48. Then we have as mass per charge of 21, which is extremely small because look at the percentage of abundance, it's less than 1%. Then we have 22 right here. At 22, we have 9.25% give us a taller peak. So how do we use the mass spectrum to determine the properties of an element? First of all, we can use the mass and the relative abundance to solve for the average atomic mass. Now, the equation for average atomic mass is basically take the mass number times the relative abundance of that particular isotope plus, again, the mass number times the relative abundance of a different isotope. And we keep adding until all the isotopes are included in this equation. In this case, if we look at this problem right here, right, we have 3 different isotopes. 1, 2, 3, 20, 21, and 22. So all we have to do is substitute them in an equation. We have 20 for the first isotope times the relative abundance. This is in percentage, so we have to convert to decimal by dividing by 100. So we have 0.9048. That's the first isotope. So this isotope 1. And then here we have, you can call this neon 20 for isotope. Then we have neon 21 isotope. Here's a mass number times the relative abundance converted from percentage to decimal. And then we have neon 22. And we don't have any more isotopes because there are only 3 isotopes for neon. We plug everything in a calculator and we solve it out, and it turns out it's equal to 20.1877 AMU. This stands for atomic mass unit. And if we look at the periodic table, which is our PT, neon also has 20.18 AMU. What does that mean? That means you can identify an unknown element based on the mass spectrum. Because why? Because you can use the mass spectrum to determine the average atomic mass of an element. And each element somewhat has its own unique average atomic mass. What other question can I ask about this specific problem? Now let's say the mass spectrum is not given to you. I want to give you the mass ratio and the percentage of abundance. I can ask you which of the peaks will be the tallest or the shortest. Here's the pattern. The higher the relative abundance, the taller the peak. So in this case, the tallest peak will be at mass per charge ratio of 20 because it has a relative abundance of 90.48%. And the shortest one, of course, would be at the mass per charge of 21, which it has a relative abundance of 0.27%, which is less than 1%. What other type of question can I ask you about this problem? I could ask you, but what does the existence of 3 peaks suggest? We can say that each of the peaks represent a specific isotope. If an element has a mass spectrum of 3 peaks, therefore it must have 3 different isotopes. And at each of the peaks, it represents a specific abundance of isotope based on how tall the peak is. And it also tells you the mass number based on the mass per charge ratio.